And here we go. So page 32 in your booklets. I want you to know, I need you to know that everything we do in this unit is connected. Everything, like we started with general form, but it is very much connected to this. Like it's still a parabola. It still has a vertex. Yeah, go ahead. It still has a vertex. It still has y-intercepts. It still has x-intercepts. All of that. The only difference is that when it looks like this, we can draw information from it right away without entering it in our calculator. That is a little different than the general form. This is vertex form, so right away, boom, we get the vertex from it. The general form gives us the y-intercept, right? So it just looks a little different, but we're still talking about parabolas here. So I told you the three ways that we can in this form right away identify how many x-intercepts are there. Right away, we can determine just by looking at A and K, right? I highlighted that. And so let's continue our journey here. Make sure you look at this from time to time to just remind yourselves or have this on your study sheet. I don't want it to take up too much room. You're probably going to need it for other stuff. So I wouldn't necessarily recommend you having this on your study sheet because it takes up a lot of room. Just try to look it over and remind yourselves, okay? So midway, page 32. So for this form, the textbook doesn't really dedicate a whole lot of time just with this form. So you will have to go, the pages that I assign plus the workbook, this notebook will have a little bit of questions there for you to practice. So you're going to have to just get your practice out of those two resources, okay? How many x-intercepts are there? Explain. So again, and I'm going to use a highlighter here. So if I want this, right, just to know how many are there, I'm going to look at A and I'm going to look at K, right? This is A and this is K. Okay? So this one doesn't have A, B, C. You know how the general form had the value of A, value of B, value of C? This one, the only common letter from this to the general is that A value, the front value, right? The leading coefficient. So in this case, we would say A and K have same signs, therefore no x-intercepts. Okay. And I feel like I wanted to add something here. So first of all, you should notice that this is in vertex form. Okay, because it has brackets. Obviously, we are in vertex form, so there it is. Okay. Notice that we could have identified the vertex from this by just changing the sign of whatever's inside the bracket. That's kind of like the x value that we get from, and this is -5, right? So we could find our vertex straight from that. Next one here, we have brackets. Okay, brackets, vertex form. So then you need to focus, okay, if it's vertex form, I know that that's going to be A, that's going to be K. So A is positive, K is negative, opposite signs. Right, therefore, 2 x-intercepts. Okay, it will cross the x-axis twice because this tells me, right, that it's pointing up, and this tells me that the vertex, if this is your x and y, it will be -6, right? It will be somewhere in the -6, like that's like the min, right? It'll be the -6 line. We don't know. That's all we kind of focus on when we're identifying how many x-intercepts there are. But the vertex, I can tell, right? it's going to be positive 3, right, negative 6. And notice that the sign always changes. And if you're having trouble like wrapping your head around that, if you were to type this into your calculator and actually find the vertex, you would get these coordinates. It would just end up being this, right? So you can confirm that that is true. Okay. Next, every once in a while, you're going to have to figure out what the y-intercepts are algebraically. I need you to be able to do that. Okay. And this is similar to what we have already done. We have found f of 5 or whatever. But let's say, let's use this one here. For a, right, we would just let x equal to 0, because that's what the y-intercept is. So basically, we are on our quest to find 0 blank, right? That's going to be the y-intercept. So let's go up to the top here, and we just go y is equal to negative 2, 0 plus 4 squared minus 5. We love zeros, right? And when it comes to plugging in and solving algebraically, it's one of our favorites in math, right? 4 squared, like 0 plus 4 is just 4 squared, minus 5. And we can keep going and just go negative 2, 4 squared, minus 5. That's negative 2 times 16 is 32, right? So negative 32 minus 5. So this would be negative 37, right? So now you can go back and actually complete this statement and say that, hey, the y-intercept is actually 0, negative 37. Okay? Or use second trace 1, x is equal to 0, right? Like you could have used that for this particular case, but we chose to do it algebraically. Let's do it for that second one here. For b, we're going to be a little tight in terms of space, but that's okay. Watch its note, it's in function notation. So I just want you to see that you don't have to fear it. It's just a little different. So we plug in 0, right, for x. And then it's 4.8, 0 minus 3 squared minus 6. And here's just a little, you need to watch out for the negative here, because f of 0 is just 4.8. 0 minus 3 is minus 3 squared minus 6. Do you know what happens when you take a negative number to an even power? What happens to the sign every time? It's going to be positive. Even power, right? Do you remember that? Anything to the even power, if it's negative, it's always going to end up being positive, right? So if this had been to the power of 4, you would still be guaranteed a positive answer. So anyways, 4.8.
Hello?
Yes. Yes.
You see that? Can you transfer down to the office, please?
Sure. Yeah. Okay. So we go 4.8, right, times 9. Oops. Get this right. You use your calculator if you need to, right? 4.5 times 9 would have been 45, so we know we're on the right track. So minus 6, right? So that's 37.2. So what you just found is 0, 37.2. Okay? Very similar to the other one, except for it's positive and it's 37.2. So anyways, the steps are always the same. And you might be wondering, Mr. Dirks, do I need to show every single step like that? No, not really. I'm okay if you show me how you plug it in, and then maybe just I'm fine after that you plug it in there, just showing me maybe one intermediate line and then the answer. I'm fine with that. I'm just showing you here exactly what happens, right? Okay, so if you haven't done the homework that I assigned here, that is what would kind of be specifically this part, okay? Let's do some graphing here. So we go to the back side to page 33. Actually, first I want you to try A to C. That you should already be able to do by now. Okay, so A to C, how about you take a minute and a half per question. Just do this right now on your own. See if you can manage. And I was looking at the homework real quick. If you come across word problems, like if I assign stuff that involves word problems, just hang on for a bit, okay? Like you can still try it. I'm not saying don't try it, but I haven't covered word problems yet. I am getting to that. So just skip them for now. Just do the ones that you know, right, that have no word problems attached to it. So let's go to page 33 here real quick and just do this before we start graphing again. Okay, so narrow, that means that A has to be greater than 1, right? Sorry, let's do this again. There. A has to be greater than 1. Vertex is given. So if I give you a vertex, you kind of know already that you're going to have to do this in vertex form, right? So there's your vertex, 2 x-intercepts. That means that A and K will have opposite signs. Okay, that's what that tells you, right? So we can go ahead and write it. A is 3.75 if you want, right? Anything bigger than 1. And watch this. X, what will it be? What will the sign be? Positive, right? And if you don't remember, if you go by this formula, by the general equation, basically, if you were to plug in, if this says minus whatever your x value is, right? What happens when you do something like this, when you plug in that -2, right? That it turns into positive after all, right? So plus k, which is 4, and I will actually do the highlighting part here because I need you to make sure you follow, you keep track, right? So this -2 here got plugged in there, and that 4 is there, right? So whatever the sign is of k, whatever the sign is of the y value of the vertex goes in there, okay? So then to basically the negative and negative turns into a positive, right? And so that would be one example, right? Answers will vary, right? Answers will vary, and that's okay. So that's that. Next, you want something that's wide, points down. Hey, points down, I know that one, right? If it's wide, I know that A has to be between 0 and 1. 1 x-intercepts in vertex form. What does 1 x-intercept tell me? It tells me that k is equal to 0. That's what that tells you, because the vertex will be right on the x-axis. Does that make sense? Yes, it does, Mr. Dirksen. Not really. I'm still waking. I'm waking up, Mr. Dirksen. Okay. So f of x would be I need it to be negative. I need it to be between 0 and 1. So 10 over 11. How's that? And then it's going to be x. And now what? What do I do now, Mr. Dirksen? I don't know what to put in here. Whatever you want. Whatever you want. The x value of the vertex will not make a difference. So let's make it ridiculous, right? Right? Just to make the point that it doesn't matter. Don't forget to square. And then we're going to go, you would go plus 0, but it's really not necessary, right? So let's clean that up, though. right? That would be your final answers will vary. Maybe I will make a note. The x value or h, right, of the vertex doesn't matter. Okay, that's a little cloud on the side here. Another one, normal points down, that means A is going to be negative, has a y-intercept of this. Wait a minute, y-intercept? Oh, it's general form. That's fine, I can handle that, right? So general form looks like this. The y-intercept is really, they're giving you the c value, okay? And so let's try this. Let's go h of x is just -1, right? -1 x squared. B doesn't matter. Let's make it ridiculous, okay? It could be absent. It could be just, you can just omit it, but you got to make sure that you have that c value at the end. Right? Tacked on there. In this case, B doesn't really, B is not really going to make a big difference, okay? Poor B, right? Yeah, you can come along for the ride, but really you don't matter that much. You're discriminating a little bit, right? All right. What if I ask you to graph? And I want you to know that you should be able to graph without a grid, okay? Maybe use a ruler, use whatever you need to make your axes, right? And to have an appropriate scale on there. So watch this, graph the following without using a graphing calculator. How would you do that? Okay. Well, the first thing you should be able to draw from this is that your vertex is 1, -9. That's point number 1. Okay. You got a point right off the bat just by looking at it. You recognize that it's in vertex form, and there you go. Point 2. What should I pick as point 2? How would I find point 2? Y-intercept. Let x equal 0. Okay, let x equal 0. So you basically just take that one. F of 0 is 2 times 0 minus 1 squared minus 9. That's 2 times, what's 0 minus 1? -1, right? Minus 9. That's 2 times 1, right? -1 squared is just 1, so that really just turns out to be 2 minus 9, which is -7. So 0, -7, -7, very important, is my second point. Let me box that in. Okay, point 1, right from the equation. Point 2, I had a little bit of calculating to do there. What about point 3? You're like, why do you need 3 points, Mr. Dirksen? Why not just 2? For a quadratic, you need minimum 3 points for you to be able to predict where the parabola is going. Okay, so point 3, I'm going to show you a trick here. So just stand by. Let's plot our points. Vertex is 1, -9, correct? 1, -9. Put the vertex, plot that point right there. Which way is this pointing, by the way? Pointing up, right? So we know you should be able to read and predict. Okay. Then we have what? 0, -7 as our y-intercept. That is here, right? And watch this, guys. This is where the axis of symmetry is going to be your friend. So I would encourage you to draw that. The imaginary, it doesn't really need to be part of your graph, but for notes, for this example in particular, I want you to just know that it's there, okay? Axis of symmetry is that what we call the line, but the equation would be x is equal to 1, right? So you almost want to imagine that you're going to fold this parabola along that line. So watch this. If you go from the center to either side, it should always take you the same number of steps to get to the legs, right? So if you go from the center, how many steps do you go to get to this point? One step, right? So how many steps would you have to take to go to the other side? You guessed it, one. Right? Now you have 3 points, okay? And because I asked you to do this without a calculator, we are not finding the x-intercepts, right? We're just there. From there on, you just curve and just go, right? Go like this and go like this. How did you find that third point? We use the axis of symmetry. So I'm going to highlight that one. That's point number 3. This one. Okay. What are the coordinates of that point? 2. And it's the same as your y-intercept, right? It's the same. It's across, just across the street, right? So -7. So point 3, I'm actually going to make an arrow from here to there that it's 2, -7 using the axis of symmetry. There you have 3 points. Go for it. And some of you are like, but I want the x-intercepts on there. Then go ahead and find them using your calculator and get the exact coordinates, but I would not expect that of you if I ask you to do this by hand, like without using the graphing calculator, which will be here and there, not very often, right? Because I can't control whether or not you type it in and you actually find it all by hand, like with a calculator. I don't know, and I'm never going to really check, right? I'm not going to be the investigator here. But you should be able to do this without a calculator. That's what I'm trying to get at. Okay, let's keep going. This is going to be your homework. I would say right off the bat, because some of you are doing your homework on a regular basis, I would say wait until word problems, right? Wait until we cover word problems. Otherwise, you're going to scratch your head a little bit, okay? So I would say don't do it yet. Don't do it. So I'm going to give you time in class today to start on this. So basically pages 34 and 35 on this in this book. Okay, so at the very top, we're going to write down homework, page 34 and 35. And you can expect an AC on like stuff like this tomorrow, okay? This is what I want to add here. You're going to probably not be too happy with me, but I think it's worth your time. So there's all these things that you need to do for A and B. I want to add a 5th option, which is graph. Okay? Make your own grid. So what I would say is, by the way, folks, these things are characteristics of the quadratic. We've been doing that over and over. You're drawing information from it. Make an inventory on the left here. And when you have that, then start your grid. Leave the right side here for your grid with the correct scale and all of that, right? You can handle that, right? And then the page 35, you don't have to graph those. You just fill in this chart. And I will post the key to both of these pages by 5 today. Okay, by 5 this evening. If it's not showing up by 5, you send me a message or an email. It's like, hey, how come you're not posting the key, right?